pleased to be here and addressing you. By way of agenda, um, the thrust of today's message is that Mack has developed a non-diaphragm pulse valve. It replaces the 60-year-old incumbent technology that's typical in pulse jet dust collectors. And what we're going to talk about today is how that design, that technology, produces maintenance savings, saves energy by virtue of its performance, and even extends filter life. It extends the life of your cartridges and your bags. Towards the end of the presentation, we'll talk about how Doug and his team at Air Hydropower can quantify that. We're not going to ask you to make a technology decision today or at any time in the future. We want to help you make a good business decision, and so we'll be discussing ROI. And typically, we find that the payback on a Mack pulse valve is for many, if not most, of our customers less than a year. So, by way of backstory, if you're familiar with Mack valves, great. If you're not, Mack's about a 70-year-old company, but for the vast majority of that time frame, we've been what I would consider in the general purpose pneumatics market, moving cylinders essentially. But about 15 years ago, we did a conventional, what I'll call a conventional but very, very challenging pneumatic application in the tire and rubber industry. We were working in their mixing department, which is a very, very difficult environment, probably not unlike some of the challenging environments and materials that are dealt with in the chemical industry. They worked with carbon black, a very, I'll call it almost an invasive material. It gets everywhere. It gets into everything, including the pneumatic systems, and causes problems. So we were replacing the valves that controlled the mixing rams, large pneumatic cylinders that held the rubber in the mixer, and replacing the valving on that. And what we did was we employed a technology that's really the calling card of Mack valves. It's called the bonded rubber spool. At one point, many, many years ago, it was a patented technology. It remains an exclusive Mack technology because it's a very, very difficult and somewhat costly process, but it produces some substantial benefits. And this tire manufacturer realized those benefits. The Mack pulse valve the Mack bonded spool valve that you see the cross section of here in the lower right hand corner, reduced substantially, almost eliminated unscheduled downtime. It reduced cycle time. They were making more batches of rubber. They were buying less rubber from outside, and it was a very, very successful project for them. So much so, they said, can we apply this technology up on the roof? Now in 2005, we had to say, well, what's up on the roof? And that's when they introduced us to pulse jet dust collection as an application. They had about almost 400 pulse valves in and around the mixing department. So most of them were outdoors, some of them were indoors, but most of them were outdoors, on anything from nuisance dust collectors to bin vents to receiver vents. And because of their location, they were, experiencing between winter and summer a good 100 degree Fahrenheit temperature swing. So in the winter, they had cracks and leaks. In the summer, the temperatures swung, and they had, again, they were baking in the sun. They had dry rot and cracks, and what they were experiencing was a diaphragm life of about a year, sometimes a little less than a year. But when he included all of the components in that system, the remote pilots, the pneumatic connection between pilot valve and diaphragm valve and the fittings and such, this plant had a nearly daily maintenance event of some nature, of some kind or the other. And what's noteworthy here is that when a diaphragm valve fails, it fails open. So you see numerous diaphragm valves on a little header here. When one of those valves fails open, you've essentially lost the whole collector. You've lost pressure for all the valves on that header to be effective. And so there is a tendency towards this sort of failure affecting production. If you lose one valve, you can sometimes lose production on that portion. Likewise, because they flow so much air, you can reduce plant air pressure in that region and also affect production. So it's a very costly sort of leak, but both from a maintenance, energy, and process perspective. So at the time in 2005, we did not have a pulse valve, but what we did, or I should say what the plant did at fairly great expense, was to adapt what we had, adapt what had worked downstairs in the mixing department to their dust collector. So here you see we began to use the same valves, inline valves, and they put on elbows and numerous fittings and plugs and such to turn our three-way valve into a two-way pulse valve. And they did this over the course of 2 years, replacing all of those 375 plus diaphragm valves with MAC bonded spool directional control valves. And they went from having nearly daily maintenance events to, in the 10 or 12 years that these valves have been installed, we replaced exactly 0 spools. So along this process and seeing the success that this customer was having by adapting this MAC technology to this new application, that was an indication to us that what we were good at, the technologies and the manufacturing techniques that we had developed over many, many decades, they lent themselves well to this other application. And consequently, we designed what I would deem a purpose-built pulse valve, a true pulse valve. So I'd like to show you very, very briefly some of the anatomy of that valve. What we did is we designed in the industry's first manual operator. Operators and maintenance people love this. That is the ability to go up on a dust collector and with the tip of a pen or a screwdriver, hit a button and manually cycle the valve. It's great for manual cleaning cycles as you're going into shutdowns, making sure that you go into that shutdown clean. And if troubleshooting became necessary, you could use that to your advantage as well. At the heart of the MAC pulse valve is that bonded spool. So instead of having a diaphragm, we use that bonded spool that we had so much success with in this story I just shared. In an effort to create what I consider a default closed position, the MAC pulse valve uses a very, very robust return spring, 12 to 16 pounds of force, ensuring that spool defaults to a closed position. We're trying again to design out the failure mode so common in a diaphragm pulse valve. Part of being able to accomplish that is changing the way the valve shifts. So our pilot's not a two-way pilot, which is diaphragm convention. We use a four-way pilot, and we move the spool back and forth exactly how you would use a four-way valve in your process to move a double-acting cylinder. So there's positive pressure, positive forces on both sides of the cycle of that spool. And then finally, we use an integral solenoid, and meaning instead of having a pneumatic connection between the solenoid or the control board and the valve, we have an electrical connection. So again, in the conventional architecture, if that connection gets interrupted, broken, the valve goes open. With the MAC integral solenoid design, if that connection between timer and valve were interrupted, cut, unplugged, what have you, you would lose one valve, but you would still have all the pressure you needed for the remaining valves to be effective. So having done this, and this was 2013, 2014, we began to market this product. And I'll be frank with you, we got off to a bit of a slow start. To our chagrin, daily maintenance events, daily diaphragm failures were not the case at every plant that we called on, and far from it. But in 2015, we made a discovery that really changed our approach to this valve and to this application. We called on a pet food plant in Georgia. And they had a rather unique process. They were making dry dog food, but they maintained human safety, food safety standards, and consequently, they did not use chemical pesticides. They used a heat treating process. They took the ovens that would otherwise dry or cook the product, and they used it to elevate internal plant temperatures above 200 degrees Fahrenheit to chase out mice and kill bugs and so forth. And what they found is following that heat treat process, they would have numerous failures on their dust collectors, numerous diaphragm failures and component failures. So the maintenance department commissioned a 7-valve trial on a cartridge system, not exactly like I'm showing here, but on a cartridge system, vertical cartridge system. And it was in a portion of the plant where there were multiple of these collectors, each one supporting a line, which was an extruder and an oven paired together. So this test was going along just fine when it caught the attention of the energy manager. Now, this plant, and more particularly the energy manager, they were evaluated on a very unique metric. And maybe some of your plants use the same metric. They tracked how much product, how many tons of dog food were produced as a function of how much compressed air was consumed. And so this energy manager was tasked with changing that ratio to the advantage of the plant and reducing how much energy, how much compressed air was being consumed in production. So he came by where this trial was taking place and noticed two things. First, that the differential pressure, the metric by which we gauge how effective those valves are functioning, the differential pressure on the collector where the Mac Pulse valves have been installed was lower, substantially lower than on the adjacent collectors. The other thing he observed was the Mac Pulse sounded like it had more punch, more cleaning energy. And based on that theory, and with the objective of reducing compressed air usage, he went to the timer board. These were clean on time systems. In other words, they were pulsing at a regular interval as prescribed by the timer board. The off time was 7 seconds. In other words, there was one pulse every 7 seconds. So based on his observations, he doubled the off time on the collector where the Mac valves had been installed. So instead of pulsing once every 7 seconds, that frequency was reduced by half, and there was one pulse every 14 seconds. So he let that ride for a little while. After a few weeks, differential pressure remained low. He went back to the timer board and he doubled it again to 28 seconds. To make a lengthy story short, this energy manager found that one pulse every 30 seconds maintained a differential pressure slightly better than the diaphragm technology on the other dust collectors at pulsing every 7 seconds. So this was kind of a game changer for us, and it certainly changed our approach, but it produced as many questions as it did answers. We didn't know, for example, if they were consuming more air per pulse, and it became a wash. But about that time, we received some lab evaluation results from a dust collector manufacturer in the Midwest. And they had evaluated and compared their existing diaphragm valve to the Mac Pulse valve, and sent a pressure trace saying, I think you guys are going to find this interesting. So this is that pressure trace that they sent us. In yellow, the 3/4 inch diaphragm, and in blue, the 3/4 inch Mac Pulse valve. And the first thing that this graph answers for us is in terms of consumption. The amount of air consumed per pulse by the Mac Pulse valve is no more, no less than the diaphragm pulse. So when this pet food plant was able to reduce pulse frequency by 75%, indeed they were realizing a very, very, very substantial air and energy savings. The second thing that this begins to answer for us is, why was that even possible? Why can one valve be more effective than another? And it really comes down to the speed at which the valve actuates. Now, we can, in an offline discussion, get more into this, but what I'll tell you this is the role of the pulse valve is not to blow dust off of a filter. The role of the pulse valve is to create motion in the filter by creating induced air, or the Venturi effect, if you will. And because the MAC pulse valve opens faster and closes faster, it creates a pressure profile that is more effective at creating that induced airflow, that motion in the filter. So that's how, with the same amount of air, we can accomplish more work. It's a function of bringing a different technology, a different performance quotient to the equation that's more effective at fulfilling that role of the pulse valve. I'd like to show you real quickly what that looks like in a specific instance. This one is sugar. And the reason why I chose to show you a sugar case study is sugar is one of the most difficult materials we deal with. It's very, very hygroscopic, and in the presence of moisture in the ambient environment, or moisture as introduced through the compressed air system, a very, very common thing we find, it produces a shell. The filters blind over very, very quickly. So this is at a breakfast cereal plant. This filter is over a packaging line that ordinarily runs 24/7. And every 3 to 4 months, this filter had to be taken offline. This packaging line had to be taken offline for 8 hours so that they could replace the filters. So when they were down for one of those filter changes, this is not, by the way, a prerequisite for a MAC pulse valve trial. When they were down for clean filters, they replaced one diaphragm valve with a MAC pulse valve. Now, as we get a little further in this, I'll describe for you why we no longer facilitate one valve trials, specifically one valve performance evaluations. But that's what we did at the time. And if you look real closely here, you can see that one valve. I've circled it in red. And what I'll point out at this point is that the existing diaphragm valve base is still in place. In other words, via an adapter, we've created a solution that really just bolts on. So installation is very, very simple. So this one valve was installed, the collector was brought back up in line, and they began to check on it periodically. 19 days in, they opened up the collector, and this is what they found. 7 of the 8 rows were substantially blinded, and one row, the row that the MAC valve was cleaning, was very, very clean. For many applications, and dare I say, for every application in chemical, this filter would be too clean. So when I say we don't facilitate one valve trials, it's in large measure because of this. We need a full complement of MAC valves that can then, the pulse frequency can then be tailored to the energy of the MAC pulse valve to give you the requisite amount of dust cake, the requisite amount of differential pressure to ensure that you don't create emissions and you work within your Title V permit constraints and so forth. But it's a great illustration of what we mean when we see and say that the MAC pulse valve has more cleaning energy per pulse. So that was, as I mentioned, that was a great discovery for us. That brought up also another question. The concern then was, if we're pulsing with so much more energy per pulse, are we going to accelerate the wear of the filter? We're pleased to say, after watching this and measuring this for a good 5 years, that that's not the case. Actually, what we've found, and what I teased at the beginning, is we found that filters actually last longer with a MAC pulse valve, and here's why. The short answer, perhaps an incomplete answer, is that by pulsing less often, there's less wear and tear in the filter. Excuse me. You may recall that we said that the role of the pulse valve is to create motion. So obviously less wear and tear, we would expect those filters to last longer. And while that's true, the more accurate, the more complete reason why filters last longer has to do with something called particle migration. So when a dust collector manufacturer designs a bag house and specifies air to cloth ratios and filter media and so on and so forth, they are banking on a process called surface loading. They are anticipating that a certain amount of your processed dust will surface load on the filters, that it will add to the collection efficiency of the dust collector and help you meet your particulate matter permits. Now, every time one of those filters is pulsed, the relationship between those fibers changes. It becomes more porous, if you will, and that allows for this process called particle migration or depth loading, where particles move from the exterior to the interior of the filter media itself. And what we see is, for example, in cement and steel industries and perhaps your plants as well, many heavy industry plants, before they make the decision to replace their filters on a wholesale basis, they will send a filter to a lab. The lab will look at a cross section, and what they're looking for is this evidence of particle migration. So how do MAC pulse valves extend filter life? Well, by pulsing more effectively and reducing pulse frequency, we reduce these particle migration events, and filters maintain a longer life as a result. So I've moved to this in quite rapid succession. Actually, I've gotten a little ahead of myself. So when we talk about filter life extension, how much are we talking about? Truly, your mileage may vary. I'll share with you some anecdotes and kind of a guiding principle. But the pet food plant, they had a normal filter life of 9 months, and by moving to the MAC technology, they today are achieving in excess of 18 months, almost 2 years between filter changes now. The cereal plant, the sugar case study I shared with you, they went from 3 to 4 month filter changes to, coincidentally, also 18-month between filter changes now. So what we find is where normal filter life is short, less than say 2 years, we can make a pretty dramatic impact on the filter life in terms of extending it. It is somewhat related to the amount of pulse frequency reduction, and obviously all that is somewhat contingent upon how appropriately the dust collector is sized, and you know, the amount of dust load and so forth. But again, the shorter the normal filter life, the more dramatic effect we have as we get into filters that have 4, 5, 7 year normal filter lives. We don't expect doubles and triples of the filter life, but as a function of this pulse frequency reduction and reduced particle migration events, we do see that filter life is extended. So what I'd like to do now is just share with you a few highlights of customers who have adopted this technology. The first is in the cement industry. This was on a main kiln bag house, a very large bag house, and with the assistance of the distributor there, our MAC distributor there, we replaced the entire cleaning system. The blowpipes were left in place, but new headers and of course valves and unions and so forth were all replaced. This collector had approximately 540 valves, and this project was very successful. The primary benefit here was not energy savings, it was not filter life, it was process improvement. Many process dust collectors, the amount of product that can be put through them is in correspondence to the effectiveness of the cleaning system in managing differential pressure. And so that was the case here, and it produced a very handsome ROI, less than a 1 year ROI, because of the increased production that they could put through this process. I'll share with you that this project received a Maintenance and Reliability Project of the Year award internal to this company. A little closer to my home, a project that I was very involved with was at a steel mill here in Detroit. When we arrived, they were considering and had actually received quotes to replace their B2 blast furnace baghouse at a cost of nearly $2 million. But as we worked with them and as we asked them questions and really were trying to determine what was driving this decision to do a wholesale replacement of this baghouse, we felt confident that we could improve substantially the challenges they were having simply by replacing the pulse valves. And so they made, in this case, about an $85,000 investment, including fittings and labor, to replace 160 pulse valves, and it had solved their problems. So there was about a $1.8 million cost avoidance. And consequently, 2 years later, they replaced their other blast furnace baghouse with Mack pulse valves. It was slightly larger, and many of their pneumatic conveying applications have been converted to Mack as well. Finally, I share with you an industry, or I should say, an application where emissions are concerned. This is lead acid battery production. When Doug said we were going to be visiting primarily with chemical plants, I wanted to make sure I addressed the emissions side. So we took a very data-driven approach to this conversion. This was a plant conversion, by the way, that's still underway to some extent. We installed flow meters to measure the before and after, and we're very, very careful that we're in tandem watching differential pressure. Differential pressures basically an expression of collection efficiency and is related to emissions. So we didn't want to save air at the expense of causing emissions. So what this plant has done is, to date, they've installed almost 500 of 600 valves in this plant. And through flow meter validation, we've determined that in terms of the compressor demand for dust collectors, that compressor demand has been reduced 61%. We are confident that, matter of fact, I think we're already there, that this plant is going to send one dust collector into idle. It was actually a rental compressor, so in this case, it will go back to the rental house. But compressor demand has been reduced and emissions have been kept in check. So in terms of next step, I don't want to step on Doug's toes here, but as I mentioned before,
and actually, Anthony, if you don't mind, I'm going to jump in with a couple examples from our customers, and just quickly show the numbers on some of those. So
sure. You want me to release the screen, or?
Yes, please.
Oh, looks like you've done it. Okay.
Yeah, and so the first one is just strictly energy savings. So this was at one of our customers here in Louisville, smaller collector, as you can see, just 6 valves, and they knew from having a flow meter installed that that they were having excess leaks. So sometimes close to 73 SCFM on their collector, and so they had 2 collectors side by side. They replaced 6 valves on one collector, and they noticed after a month of testing, they had the side-by-side comparison of using the Goyen valves versus using the Mack pulse valves. And so as you can see, just based off of the savings of the leak, the actual air consumption, you're at a little over 2 months for an ROI on that. And that was, we did not take into consideration any of their filter life savings, maintenance, really very little, or process improvement. So even just discussing one aspect, it was a big win. And then the second one, certainly our largest one, was at another chemical facility where, as you can see, it was process, and this has to do with the reliability aspect, to where 4 times a year. And they noted this because they had the work orders specifically called out for stopping a dust collection in the process for changing out diaphragm valves. And so they knew that this happened 4 times a year on average, and it took about 8 hours for the machine to be shut down, switched out, and then start up again. And each one of those cost $80,000 in production and process improvement. And so this was what Anthony kind of talked about, that cost avoidance, and then of course the maintenance that was part of that. And so as you can see, for a 52 valve collector of a $30,000 investment, it was a very easy for them to recoup that money. So just a couple of real life examples that hit home for us, just so that you guys are aware that we have this documentation and we have been seeing the success with our customers. So with that, Anthony, I will send it back.
Doug, you can just keep that on your screen.
Okay.
My only closing remark would be this: that what we want to do is really help you make a good business decision. And what Doug is showing there is kind of the end result of a process, an ROI process that they can do for you at no cost to you and at no obligation. It does two things. One, what they can do for you is establish very, very accurately the total cost of owning your existing dust collector. One of the things that clouds decision making around these assets, and one of the reasons why dust collectors are so neglected, is because nobody knows the true cost of operating it. Maintenance on the collector comes from one budget. Many times filters come from facilities, which is a different budget, different area of responsibility. Energy is paid for out of another budget, and if there's interruption and downtime, well, obviously operations is absorbing that cost. So what Doug and his team can do is put all those numbers together and say, this is how much money's on the table. This is the total cost of owning, excuse my vernacular, this is the cost of owning a cheap valve. And then what they can do is project in what sort of savings are typical to these applications and say, okay, given our experience, if we can achieve a pulse frequency reduction of X, leakage reduction of Y, maintenance savings of Z, it will create an ROI of what have you. So it will allow you to do things. One, determine if it's a good use of company resources, and two, it'll help you prioritize systems within your plant for retrofit. We do find some low ROIs like Doug has here. Most typically they fall between 6, 7, 9 months, maybe a year. Sometimes we find in cases where dust collectors are oversized or not in continuous use, sometimes the ROI is over a year, even over 2 years. So Doug's this process of generating the ROI is very, very useful in determining if and to what extent this technology is good for you. But I will say this: we've Mac and Air Hydropower, we've had a very, very long, many decades long relationship. We've never found an application where the incumbent technology had been so static for so many years. And we believe the benefits to your company are going to be substantial, and we'd like to be a good working partner in establishing what those benefits are. So our encouragement is that you work with your Air Hydropower account manager. Matter of fact, I'm going to ask Doug to direct that they reach out to you to determine if you have any questions. What they can do by virtue of essentially a one-page data collection form is help you begin to build this business case for conversion. Some of the process is dependent on identifying exactly what you have now, not simply that it's a Goyen valve or an ASCO valve, but specifically what model you have, what casting that model came from, so we can appropriately prescribe an adapter and keep the installation very, very simple and clean and without incident for you. But with that, I'll kick it back to Doug. I thank you for your time and your consideration. I think we've got something very, very important for your business.
Yeah, well, thank you again, Anthony, and thank you all for attending. And we'll be reaching out to everyone who attended and customers as well. Thank you very much, everyone.
And if there are any questions, we could certainly take questions now. Like I said, otherwise we would be absolutely thrilled to take this discussion offline with you guys individually.
I think we are good for now.
All right, Doug, thanks for the invitation.
All right, thanks, guys.